My name is Matej and I'm an Android engineer at Futured. And today I want to talk a little bit about how we shared or how we shared navigation or how to share navigation in Kotlin Multiplatform. You see, a few months back, there was a question raised in our company: how far can we push things in KMM? What can we share? And you know, like you usually share your data layer, networking, and stuff like this. But we asked ourselves, could we share navigation even? And yeah, so I'm standing here a few months later with the results of our experimentation, and I want to share them with you. This talk is gonna be Kotlin Multiplatform talk, and we're gonna talk about how to implement the UI part in SwiftUI and Decompose with fully shared navigation logic in KMM. Before that, I want to talk about core navigation concepts that are present in each of the platforms. So, just to check again, how many Android devs do we have here? Okay, not many to be honest. How many iOS devs? Nice. You're gonna learn something new today. Yeah, so just so we are on the same page, let's go over the core navigation concepts. Nope. Okay. MacBook Pro. Their screen. Nice. Okay, so let's continue. Hopefully we caught that at the beginning. So yeah, so like the basics you get is like pushing and popping the screens. And you can see that on Android we are used to do it maybe custom. However, on iOS this presentation of the screens is really integrated into the system if you want to have that native feel in your applications. So you can swipe the screens away and stuff like this. The next thing is that, and by the way, what you see here is our internal demo that we iterated on. So this app that I'm showing has fully shared navigation and everything except the UI. So on Android, we are used to go, when navigating back, we are used to go just to one level back. However, on iOS, you can do stuff like this. You can hold your finger on the back button and choose how many levels you want to go back. And this is really important to know if you want to share the navigation, because you have to count with that. Another things are dialogues and alerts, pretty standard stuff we know with the both platforms. Then we have sheets, and this is where the things get interesting, because sheets seem to be really integrated into the system. You can see they have these nice animations pushing the previous screen back, and you can even stack multiple sheets onto each other. This really blew my mind as an Android dev when I started to learn about this, when my iOS colleagues told me, because we are not really used to do this on Android. And sure, you can do this, but I mean, it looks just plain ugly. You wouldn't do this in Android app. So yeah, and you can see how the sheets are vastly different from Android, because the sheets can be as prominent as other screens in your application, and they can even have like the nested navigation inside of them. And when you combine these two previous screens, you get madness like this, which really blew my mind as an Android dev, because you can stack multiple sheets onto each other, and each sheet can have its own navigation. And so that was the challenge for us, how to design this in Kotlin Multiplatform, so this basically works. So how would you display a native UI without KMM? In SwiftUI, we actually had to go with something native. And there's a little backstory, because when we came to to iOS devs in our company, they were like, "You're taking our jobs. but not really. But yeah, if you're gonna take our jobs, at least do not take the native experience away from the user. And so they told me that if we want to do this, we must use navigation stack or navigation views in Swift UI, because that's what they use in iOS apps, and that's how you get that native feel. That's how you get these back button callouts, and that's how you get gesture-based navigation on iOS. So we need to work with that. And the navigation stack works by stacking screens into the path where the last object on that path is the topmost screen in your app. And notice this binding. You can modify the path externally, like when the user clicks on something, you can add something on the path. However, when the user navigates back using gestures or toolbar, this path the system must have a way to overwrite this path using binding. That's when the set method gets called. In Jetpack Compose, it's really like you can do whatever you want as long as it has some animations and it observes the stack. I mean, you can go crazy and implement anything. So this is not gonna be much of a problem. Now, how would you move this to KMM? The basic concept would be to define some interface between your view and the shared part in Kotlin. So you could have some sort of navigation stack stored in KMM and some actions to call from the UI. And for Android, you just need a single pop because we always go just to one level at a time back. However, iOS can call pop2, which, as I described, can be used to overwrite an entire stack from your navigation stack view. And so in Swift, you can go from this to something like this. I'm not really gonna go into details, but this is just the basic concepts we have right now. On Android, in Compose, really simple, just replace everything stored locally in your composition with shared stuff. Now, this would be not enough, I guess, because when you continue, you start to ask more questions like, how does this survive configuration changes? What if I want to use life cycles? What about I can't remember the exact name of this thing, but whatever. Yeah, dialogues, overlays, and like you get this crazy stuff with the sheets, right? So we could build yet another navigation framework, but why should we reinvent the wheel? Because Kotlin Multiplatform is already in beta and it has a lot of support from the community. So we thought there must be something already ready to be used, and there is actually. So how many people have heard of this framework? Nice. Yeah, so Decompose is Kotlin Multiplatform library, which allows you to compose your components in your application. Like it allows you to compose your your business logic into components in your application, and it has robust navigation APIs. It uses child stack and child slot APIs. While child stack APIs allow you to stack multiple components on top of each other, like deck of the cards, and the child slot APIs are really useful for displaying overlays, temporary overlays such as dialogues, alerts, sheets, and so on. Now, what's the component in Decompose? The component is anything that you want to be part of your navigation tree, be it a screen or dialogue, sheet, just a view, whatever. And what's important is that component has a life cycle. So when you pop the component off the stack, you might have some business logic in that component, and you can react to that event using lifecycle APIs of Decompose. So for example, if you do some async operation in your component, you want to have a view model in it, you can kill the operation. So let's move over to stack navigation. Stack navigation works by creating a child stack in Decompose, and you get a navigator with it. Navigator is some object that can operate on this child stack, and it can basically mutate its state. And by default, you get some built-in operations that you can use, such as pushing, popping, pop file, etc. However, what I find is really nice and a really strong feature is that you can do custom transformations over your stack. And we will actually need this to implement interop between SwiftUI's navigation stack view and Decompose. The child slot APIs are really the same. Not much to do there apart from activating and dismissing children. Now, how would we connect that to the UI? So, at the start of your application, or at the beginning, at the root of your navigation tree, you would have some kind of root component which holds the navigation stack and which allows you to create children on your navigation stack. By children, I mean another components. Everything in Decompose is a component. In Compose, you could do something like this. Actually, I want to go back. Yeah, there's this value which is there. And this is Decompose way of allowing the UI part observe the changes. So whatever you wrap into the value, you can subscribe to it as a state from Jetpack Compose and from SwiftUI. So in Compose, there's this built-in composable called children, which is provided by the Decompose extensions, and it handles the routing for you. Routing as of it handles displaying the current state of the stack. So basically, you just feed it with your Decompose stack, and it switches between displayed children. It has support for animations and so on. So we don't have much of a problem here on the Android side. On the SwiftUI side, however, things can get a little bit complicated. However, it works. And what's really different about the stack stored in the SwiftUI and the stack stored in Kotlin is that the first view in SwiftUI must be always sort of hard-coded inside. And on that view, apply a navigation destination modifier, which means that you must always assume there's at least one child on the Kotlin stack, and you must pull it out of that stack, and you have to make it transparent to the SwiftUI's navigation stack views path binding. So you just do it by dropping it in the get method and appending it back when you set that to the Kotlin side. And you could actually extract that logic to the Kotlin. It doesn't matter, it's just for the demonstration. So this video shows how it's basically working. And by doing this transformation over the stack, you actually implemented an interop between SwiftUI's navigation stacks, between the navigation stack and Decompose, because by overriding entire stack, you get the back functionality, the gesture functionality, and you get the functionality of back button callout, however it is called, this thing. Yeah. So what about the slots? Slots work really similar. You just create your slot in your root component or in whatever component you want. You can create a slot in the component that is displaying your screen, and you call activate or dismiss on it, and it gets activated. And you also from the native UI, you observe that state. So in Compose, you can display whatever model bottom sheet there is. If there is some child in the slot, and in the Swift UI, you have to observe also the child value. However, we also have to use the binding, and this set method gets called when the user swipes away the sheet. So the state gets propagated back to Kotlin. Now, what about arguments and results? This is really fundamental thing in navigation because we want to pass arguments to the screens, and we also want to get results back. For example, when you display some picture, you want to get result of what user chose or clicked. And this is really simple in Decompose, and it's type safe by design because you handle all of this in Kotlin. You see, when you create your component, it is just a class in which you got your logic. And you have full control over the creation process of this class. So you can just pass your arguments in the constructor, and also you can pass some lambdas to be called when the user performs some action, and you want to notice, you want to let the parent component to know what happened. So all children on the stack are identified by a class that Decompose calls configuration. And in this class, for example, we have a sealed class in here, you can store arguments, because this destination class, which we have here, serves as sort of a blueprint to how to create the component you want to display on your stack. This destination class here gets passed as an argument, and you can pull that information out of this destination class and use it in the component constructor. So it's really easy. It's really easy and intuitive. Now, what about some advanced features? Another thing you can do with Decompose is that you have full access to your navigation stack. And this is really cool feature and really useful because you can introspect your entire navigation stack and see what screens are on it, how many of the screens are there, etc. And you can do like some cool stuff with it, like observe how many items are on the stack, and based on that, you can tell the UI if it should display the back icon in your navigation up bar or do something completely different. Another thing is this crazy feature which I showed earlier, and this is implemented also easily with the Decompose. What you see here is a rough skeleton of how would you write that in Swift UI, and what you basically need to do here is to just have one root component, and onto that you get a child stack of children. And on that root component you also show another sheet which is represented by a navigation slot, and in that slot you get another child stack, and on that child stack you get another navigation slot, and on that navigation slot you get another child stack, and you can repeat that basically forever and it will work. You can model that situation like this. It's easy once you wrap your head around it. So yeah, I'm gonna let that sink in, and I'm gonna have a sip of water. All right, to the next one, multiple backstacks. Here, it is really useful if you want to get fancy with the bottom navigation in your app. And you can really leverage the Decompose's feature of being able to compose your components into trees. So in this case, we have an app that displays three separate navigation stacks, basically. And you do that by just switching between these stacks when user clicks whatever tab he wants to go on. And each of the tab features separate navigation stack of children, which you can like push onto and pop off. And you can, by clicking between the tabs, you can just switch between them, basically. Now, on the root level, you would have your navigation drawer or navigation tab bar or whatever it is called. And at that root level, you would display this and handle its state. And in this intermediate components, you would have your UI with the toolbar and the screens, etc. Now this has a weird, or not really weird limitation, but could have unwanted behavior on Android, because, for example, when you have some screens on the first tab and then you switch to tab B, what's gonna happen when you navigate back on Android is you will close your application. And to mitigate this, you can actually do something like this. You take all of your free navigation stacks and you can actually put them onto another navigation stack. So what would basically happen here when you click the tab in the bottom bar is that whichever tab gets clicked, its navigation stack is gonna get to the front. And then when you press back on that tab, you are back at the tab A. Simple. So, as a wrap-up, Decompose is cool. You could all try it. It's really powerful and flexible. We can definitely get navigation stack interop in between Kotlin and iOS side. So you could really get that native feel of navigation while sharing the state in the Kotlin Multiplatform. And this crazy feature just works, and I've never had any problems with this. So this really has to prove that it's ready, right, for the production. The benefits are you basically get to share just another thing in Kotlin Multiplatform. And really large apps could benefit from a single source of truth for your navigation, because it can get a little bit messy when you have two different code bases and you need to handle two different navigation behaviors. With this, you get to share also that in Kotlin Multiplatform. As I already said, Decompose is very flexible and it lets you do all crazy stuff you would imagine. And there was already mentioned today that if you've been following news lately, Decompose Multiplatform has already moved to alpha. And so if you want to take a next step and also share your UI using Jetpack Compose in the future, then sharing your navigation could be beneficial, because you would get the full vertical slice of an app shared in Kotlin Multiplatform. Now, what are the drawbacks? Well, you get to write some boilerplate code. What I showed here is really not compilable code, just for the sake of simplicity. And there are actually a little bit more to it. You must set up some stuff, and it can get a little bit messy, if you will, but it's worth it. There's some learning curve to Decompose also, so you really need to read through your documentation to learn all the advanced stuff it offers. And the default Kotlin to Swift interop is not really nice, because we use a lot of sealed classes and enums, and this particular feature gets translated into a mess of words stacked together. So, but yeah, there are some compiled plugins to mitigate this. Now the question is, should you use it? Well, you can give it a chance. I encourage you to. However, you need to proceed with caution. You need to proceed with caution because this is based on the navigation stack view from Swift UI, which has been released just recently. So this would be compatible only with iOS 16. There are, however, libraries to port back the Swift navigation stack APIs back to the iOS 15, 14, etc. I've used them and they have been working like good, but you never know, right? So, but I don't think this would be much of an issue with the speed of adoption of new iOS versions, because iOS 17 is just around the corner and you usually support 2 versions back. So yeah, not much of a problem after all if you decide to deploy this in the next half year or the year, right? There still might be some unexpected quirks which we haven't encountered, but yeah, we still haven't production tested this. So this is kind of experimental for us. We are iterating on it, and we still need to verify this in a its full functionality. So, but what I just showed you like works perfectly, but you never know what can happen. You might be after all going too much into the KMM, you after all might be wanting to share too much, and it might backfire on you in some way in the future, so you need to be really careful. With that said, thank you. I hope you learned something new today, and there would be code somewhere in the future. I'm gonna try to put it in the wrap-up that's gonna be sent out to you. I still haven't I haven't cleaned it up. I was too lazy, so I'm gonna finish it. You will get access to it later. Thank you.
Thank you, Matej. I have to say that sometimes like the whole never-ending life cycle of navigation in iOS is blowing my even iOS developers.
Yep.
So it's not just for you. This time we have 2 questions. First one is probably easy one. Was the demo done with the Decompose library, or have you created everything by yourself?
Sorry, again, what's the first part of the question?
What was the demo done with the Decompose library, or have you created everything by yourself?
Oh yeah, the demo that I just showed at the beginning, like the navigation concepts, it was all created by Decompose actually, because that's what we ended up using after all. So yeah, this is fully built with Decompose.
Cool.
But do you have an abstraction over it?
Oh yeah, like everything's hidden behind the interface.
Showing us all the time was your abstraction over Decompose, joining this together somehow.
Oh yes, like in reality it looks a little bit different because I didn't want the code to be really overcomplicated, but we have some kind of abstractions over the components, like the UI actually doesn't know anything about Decompose and stuff like that, so yeah.
Yeah, there's another question, and this is a really long one. Okay, so you probably have to sacrifice a little part of the native usage patterns. For example, bottom sheets on Android isn't used in the same situation like modal sheets on iOS. Are your apps more iOS-like or Android-like?
Okay, well, as I mentioned, we still haven't used that in production, but you would have to really communicate that well with your designer. So you have to show him what's possible with the sheets, and you have to decide what component you use on Android and on iOS, basically. If that answers whoever's question was that.
And there is like an additional question, right? Or are you able to model some parts of navigation differently for those platforms?
No, you are not. You are not. However, yes, I mean, you can store 2 completely different navigation stacks in your component, each for iOS and for Android. This might be the way if you like it. I don't know. Yeah, it's definitely possible if you want to do it like this.
Okay, and last question probably from my side. Probably more like about your, feelings about it. After all, do you like more navigation in Android or in iOS? If you would go like native way.
You mean like design-wise, like user experience-wise?
Yeah.
To be honest, I was blown away by the sheets and all that crazy stuff you can get on iOS, and I really like it. But yeah, I still like material design, so I guess you have to really appreciate what each of the platforms offers you, and you have to use it accordingly to have the best UX in your application.
I have to say I like the fact that usually all Android devs say that iOS navigation is just cool.